Alright, so I figured I'd go ahead and give you a demo of some of the things that this generator is capable of. 2 channels, 2 separate waveforms, 2 separate voltages, 2 separate frequencies. Let's see, you can change the, okay, you see this asterisk, it chooses the line, so to choose the line you can press shift and set and it'll switch between the 2 lines. I want to adjust the you can adjust the frequency with the, see there, just a sec, you have to go left and right will adjust the digit you want to adjust. So you want to, so that's 10 kilohertz, so that's 12 kilohertz, and set, so we can do it triangle wave, sawtooth, reverse sawtooth, and it has this sign, of course. I'll adjust that. There you go. Okay, and let's go back here. I'm gonna go 11 kilohertz sign. There we go. Okay, now you can also combine the 2 wave. So there's a waveform combining channel 1 and channel 2, 200 kilohertz square wave, and that's on channel 1, and then channel 2 has a 11 kilohertz square wave, and that's what that looks like. So what you can do is press shift, and you see it says wave, so that'll go directly to wave. If you press shift and amplitude, you can change the amplitude, and then shift again and change the channels between 1 and 2 like this. So we're just dealing right now with just channel 1, and we're going to change the waveform. Okay, so there we go. 2 volts per division 1, 2, 3, 5, 6. That's 12 volts peak to peak, and we got 11 kilohertz here, and you can see on the scope 11 kilohertz. So looking good. As far as some of the functionality here, the page down. Okay, so you have an offset. It's a DC offset. I think that this is really cool. Okay, so let's say if you have just a sec, let's go into the DC coupling. That's what we want. So we're gonna adjust it up to 120%. Okay, you can see it starts to cut off there at the top. Then that's minus 120%, and we're back to 0. So basically your generator is outputting a plus or minus DC component along with the waveform. I think that's really cool. Duty cycle is not going to change your sine wave, but it will change your TTL output. On the back I have my scope hooked up. We change the frequency in the back. The frequency of the of channel 1 here to, let's say, 41 kilohertz. You can see the TTL in the back output lines up with it. Basically, it's a digital signal that correlates to the analog output from the signal generator. We got the if you turn on trace, it basically tracks one channel to the next, so you cannot change the frequency. They're synced up. So this is channel 1 on top, channel 2 on the bottom. They're in phase, and you can change. You can see how the bottom one now is 180 degrees out of phase, and you can go all the way to 350, and 360. So it actually continues to go, which is really cool. You can go very small amount of phase difference, you know, 1 degree out of phase, you know. It's pretty cool. And the next order of business, so that's what the trace on is. Trace off, you can see with the trace off, it doesn't sync them up, and that's why we have some triggering issues there. So I'm going to turn that channel off. There we go. Turn that one on. Center that. Nice waveform. Okay. So next up, next order of business. You can change what type of frequency. What the kilohertz, megahertz, hertz. You know, depending on where you're at, what range you're at. Let's see. I like to stay in the kilohertz. That's pretty much where I use it. You can invert it, so 2 will be inverted to 1. I haven't checked to see if you have to have the tracking on for that. I guess I'll do that right now. And there it is. So I got channel 2 is 122 kilohertz. Channel 1 is at 61 kilohertz. And watch this. It's actually inverting channel 2. So it does offer a 180 degree phase shift on different frequencies. The other one I showed you, which is phase shifting, you have to have the trace on to do that. Okay, so it does have a burst function. I'm not really sure what it does, but if somebody wants to put in the comments, that's great. I don't have time to get into that right now, maybe later. External input, so you can have either the external input up front or in the back, the TTL input. You can choose that as well. You can put OK, TTL in, OK, external in. And so, okay, so you can actually change it to read the frequency of your external input or act as a counter, and positive pulse width, negative pulse width, period, duty cycle. So that's pretty handy. I got a scope, so I'm not going to be using that, but it would be nice if you could trigger off of that, but that's maybe in a this is not a very expensive unit. I think I got it for $60 or something like that on eBay. For $60, this thing does well beyond what I thought it would, even though I had to do my little modifications to it. Let's see. Alright, so we got our sweep frequency 1 is 2 kilohertz, and then 20 kilohertz for frequency 2. So the sweep time is 2 seconds. And we're going to go linear. You can do linear or log. And I will just do that. Okay. So there's our sweep. Pretty cool. I really like what this thing has to offer. Lots of functionality for the price. And like I mean, it's $60. I mean, how much more can you get? How much lower can you get? So I'm really happy with this thing. So this was the brightness of the display before at maximum voltage, and now I set up a potentiometer on the side so that it wouldn't be quite so bright. It'd be readable in the as far as if I do a video. So. Nice. And I also tapped the 5 volts off the power supply input as well. One thing I did find that You can see when the display is really full brightness, it looks like all these 3 LEDs are on. But if you take the brightness down, you can see that only the top one and the bottom one are on. So there we go. So it's a lot more, you can see the indicators better. So this new signal generator, but it came with a couple of little bugs. The backlight I wasn't happy with. It was too bright for the screen. Also, the BNC connectors were not soldered in properly, giving me problems. So I soldered those up. After that was fine. But the backlight, you can see 5 volts, 0 volts on pins 15 and 16 of the LCD. The uppermost wire there I spliced into, and that connects it to ground. And I put a 10K potentiometer in that line, so secured it to the casing on the side casing. Everything there went well, and also I did a 5 volt, a couple of alligator wires to the 5 volt input, and then put them through the side casing as well, so that I have an extra 5 volt if I need it from the signal generator. And these are some combined waveform pictures that I took